Okay, let's begin. Today we'll be talking about the measures of central tendency. The measures of what? The measures of central tendency. Yes. So definition. The central tendency, it is the number used, or rather is defined as the number used to represent the center or middle of a set of data values. There are three types of central tendency. These are 1. The mode, 2. The median, 3. The mean. So when we say the mode, what do we mean? The mode is the score with the highest frequency. In a set of data, any score with the highest frequency is the mode. This is a video. You can pause and get this out. So we are going to solve the example. It says find the mode for each data set. So now we are going to do number 1. To answer that question, what do you do? Okay. Number 1. You have to know the scores are represented with X. And the number of times they appear is represented with F. So what is the least value there? I'm going to be writing and sending you that is there 0, no 0. There is there 1, there's no 1, I've checked. But there is 2, I've checked there is 2, so I'll write 2. Like that. After 2, what's the next value? 3, I write 3. The exam, you can use this to show mastery. Then write 4. Or use any way you work. You can use tally, like she taught us with tally. But they have to take my time, so I'm not to use tally. 6 is there, yes, 6. I think there's 7 also. 7 for number 1. So I'll now count it as I'm counting as cancelling. So now 2 now. For 2, how many times did they appear? 1, 2, 3, 4, 5. It appeared 5 times. I write 5. Did you see that? 3, how many times did it appear? 1, 2, 3. It appeared 3 times. I write 3. 4, how many times did it appear? 1, 2, 3. It appeared 3 times. I write 3. Then 5, how many times did it appear? Once. It appeared once. I write 1. 6, how many times did 6 appear? 6 appear 1, 2. It appeared twice. So I write 2. So 7, is there 7 there? Yes. Appeared once. So I write 1. So with this now, you already know the answer. These are our scores. This is the number of times they appear. Number of times present frequency. So which one has the highest frequency? It is 2. 2 has the highest frequency of 5. So solution. Therefore, the mode is equals to 2. Remember, 5 is not the mode. That's the frequency that gives you your answer. You look here to get your answer. You understand? The 1 is the highest frequency, so that means 2 is the answer. You now pick 2. That's that for number 1. For number 2, the same thing. X represents number of scores. Then F represents number of times they appear. So now we have 0 there. We have 1. We have 2. Do we have 3? Yes, we have 3. Do we have 4? Yes, we have 4. Do we have 5? No, I don't think we have 5. Let me check. Is there 5 there? No, there is no 5 there. So you start counting. 0 is how many? 1, 2, 3, 4, and 5. So I put 5 there. 1 is how many? 1, 2, 3, 4, and 5 is also 5. Put 5 there. Then 2 is how many? 2 is 1, 2, 3. Appear 3 times. You put 3 there. Then 3 is how many? 3 is 1, 2, 3, 4, and 5. So you put 5 there. 4 is how many? 1. 5 appear only once. So already we have gotten our mode. So in this case, I see 0 is 5. 1 appear 5 times. 2 appear 3 times. 3 appear 5 times. 4 appear only once. So our mode, according to this, therefore, the modes is equal to 0. 0 is 5, they are the same thing with 1 and 3. You can see we have 3 modes in this case. So 3 modes in this case. So since they have equal frequencies and they are also the highest frequency, that means we have 3 modes. You write the 3 of them at that frequency. In this first case, we have only 1 mode, so it's called unimodal. In the second case, we have 3 highest frequencies at 3 modes, so you call it trimodal. If it was 2 modes, as I said, you call it bimodal. Then if it is more than 3, you call it polymodal. So this is our answer. Any question? No question. So we move on to the next one, which is median. So I will not make the video to be very long. So now for median, you can take this down. You've taken it down. Okay, let's continue. So for the median, you come over to this side. So for the median, okay, the median, this is second central measure of central tendency. The median. Median is the middle score after all the scores have been arranged. The median is the middle score. We all know this, just to make what is short. It's the middle score after, let's get it word for word, all the scores have been arranged in order of size or magnitude. So the middle score, the median is the middle score after all the scores have been arranged in order of size or magnitude. So let's take example. Calculate the median of the data set below, of each data set. So we have 8, 4, 3, 5, 2, 4, 3, 9, 7, 7, 6. So here we have 42, 33, 46, 28, 25, 33, 40, 43, 40, and 26. So now, calculate the median. To calculate the median, we have to arrange it in ascending or descending order. So the solution, there's a method the woman taught us. It's a use any of the methods, so I'm going to breeze it fast. So solution for number 1, there's a method Miss Dami also used, which is, according to I say use any method, it's correct. So from the smallest 2, arranging in ascending order, as I'm picking, I'm cancelling. 2 is out. Who else again? 3 is next. So 3, I'm picking and cancel. I pick another 3. So I pick and cancel. I pick another 4. Pick another 4. As I'm picking and cancel, I pick another 5. As I'm picking and cancel, I pick another 6. I'm picking and cancel 7. Is there 8? 8, 9, and the last. So you will count it as she said. These are the safety measures. Oh, the markers are dying. Safety measures. Oh, so you count it. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You go back and count how many you have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It must be the same thing before you start solving or before you go ahead. So now since they are the same, I can now go ahead. So since there are a total of 11, we need to know what value is in the middle. So what's the middle of 11? Our method is you divide by 2 and that'll give 5.5. So you count 5.5 from the left to wherever you stop. The 5.5th number, you mark it. Then you count from the right, 5.5, and stop in the middle. So let me just go straight. If it's an odd number, this is an odd number, case of odd number. Because it's a set of odd number. So they are odd numbers. Total numbers are odd numbers. So because they are odd numbers, you will add 1 to the total, where n is equal to total numbers present. The total number present, number of times they are the total number of the array. So now the total numbers present is how many? Is 11. So you now say for odd numbers, you now say n plus 1 all over 2. The median is equal to n plus 1 all over 2. For odd numbers, it's for even numbers you don't do that. So let's do that now. Since they are odd numbers, 11 is an odd number. Counted 11. So n is equal to 11. Odd number. So because it's an odd number, so the median is equal to 11 plus 1 all over 2. So any number in this position is the answer. So 11 plus 1 give you 22. Sorry, 12 I said 22. All over 2. 12 all over 2 give you what? 6. So it's the sixth number. Sixth number is your median. So from that arrangement, we will now count 1, 2, 3, 4, 5, 6. So this is 6 number. So our answer, the median. Therefore, median is equal to what? 5. That's the answer of that one. Then for number 2, let's arrange in ascending order. Number 2, you have, what's the smallest number there? Smallest number is what? 25. Is anybody smaller than 25? No, so you're right. 25 followed by 26. Yeah, as you're writing, you're cancelling 25, 26. Followed by who? 33. 33. I think I paid twice. 33. Followed by who again? Is there any 30 something? No. I think next is 40. Followed by 40. That's how you look when you get to the exam or to avoid mistake. 41. Is there 41? There is no 41. Forget this is a circle. But there's 42, so you take 42. Followed by who next? Oh, 40 appeared twice. Sorry. 40 appeared twice. Followed by who again? Oh, you missed the 28. 28 is supposed to be there somewhere. I'm running against time, so I'm rushing. So, yeah, that's what you go to cancel. So canceling is helping us to know who we missed. 43, 143 is there. Then 43 again, no 43. Last is 46. Yes, to be sure I did not make a mistake, I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You now count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's when it's complete. Is it odd or even? It's an even number. So it's a case of even numbers. Because in a case of even number, what do? We will add 1. Do we add 1 to get the median? No. The median is the number at this position. And all over 2. This is not a median, but this is supposed to get a median. We have 10 all over 2. The numbers in this position, 5. You count 5 from left and from right. The two numbers in the middle, you find the mean of the two numbers in the middle. So the 5, I'm going to count 5. So now let's go. You count 1, 2, 3, 4, 5. You got 33. That's the number if you count from the left. Then from the right, 1, 2, 3, 4, 5. Yes, that's second 5. So you pick the two of them. That's 40. Then you find the mean. That'll be your median. So the median is equal to this plus this divided by 2. You find their mean for even numbers. Doing it in class. So I carry my calculator. I punch it in. I have 33 plus 40 is equals to 73. So that answer now divided, I don't know where you can see my calculator. If you cannot use your own and check it to confirm, the answer is 36.5. So your median is 36.5. That's the answer of the case of even number. Any question? No question. So we go to mean. Let's go to mean now. I know what mean is. Don't forget for median, you arrange the ascending order. After arranging the ascending order, the number in the middle. The median is the middle score after all the scores have been arranged in order of size or magnitude. That's ascending order or descending order. So if it's odd number, you add 1 to n and divide by 2. Whatever position is in the middle, whatever value you get, that's the median. Then for the even numbers, you don't add 1 to it, you just divide by 2. Then the position diameter you count from left, you count from left, 5 from the left. Then you count 5 from the right also. The two numbers that fall in the middle, you will find their mean, and that will give you the median by adding them together and dividing by 2. That's how you get the median. Oh, I'm making a mistake. I'm not giving you the attributes. I'm doing this video for the second time, so I've read the attributes the first time I did the video, so that's why I forgot. So maybe I'll finish all and then I'll give you the attributes later. But let me just give you the attribute for mean, for mode, and the median. The attributes of mode is, it is the weakest. You can write that down. For mode, its attributes, it is the weakest of all the averages. It is the weakest of all the averages. It is relatively easy to. It is relatively easy to determine. That's number 2. It is relatively easy to determine. Then number 3, there may be more than one modal value. There may be more than one modal value. Then number 4, the mode is not defined when there are no repeats in a data set. Number 4, the modes are not defined when there are no repeats in the data set. It means there are some cases of array where you cannot calculate the mode because nobody was repeated. So that's his attributes. Attributes means his features, his characteristics, his strengths, and his weaknesses. So that is attributes in case of however they ask the question, in case it comes out, and it won't be more than one question. So that's why we should not waste time on it. So the median is attributes. What are the attributes of the median? The median is the next most commonly used after the mean. These are its attributes. You may have more attributes in your notes, so you can write those ones. 2, the median is unaffected by any of the information values in the data set. It's unaffected because it's only interested in position. You understand? So it's unaffected. The median is unaffected by any of the information values in the data set. Then 3, it is the best used when there are outliers or deviant values. 3, it is the best measure of central tendency to use when there are outliers or deviant scores. So thank you very much. So we'll go to the third measure of central tendency, and that is the mean. So when we're talking about the mean, we're talking about the mean is the sum of all the numbers in the data set, or all the scores in a data set divided by the number of scores in the data set. So it's presented by this x vinculum, some call it x bar, is equals to sum of the scores all over, or score values all over number of score values. So that's the mean. You can represent it like this. Where this is sigma, the Greek, this symbol is the Greek letter representing summation of x, where x is the number of scores and n is the what, number of times the scores appear, number of scores in the data set. Then it can also be presented with this also. So these are the two ways, the two formulas for calculating the mean. Examples. One, compute the mean of the following. Compute the mean of the following list of scores. Let's just leave it like that. 2, 4, 8, 11, 12, 12, and 14. Compute its mean. That's the first example. So mean can also be represented with letter M. Sometimes can also be represented with letter M. Take note, but I prefer this one. Okay, to solve this problem, I hope you can see this down part. The solution, like this formula says, x bar is equals to, you add everything, divided by how many are there? 1, 2, 3, 4, 5, 6, 7. There are 7 divided by 7. So if you add all these things to your calculator, punch, what will you get? What will you get? Here I got 63. I'm not 2 plus 4 plus 8 plus 11 plus 12 plus 12 plus 14 is equal to 63. So it's correct. So it's 63, everything all over 7. So 63 divided by 7 give you what? To give you 9. So that's your answer. The mean is equal to 9. So that is the answer for that question. Easy peasy, lemon squeezy, they're not richy, everybody's happy. If it comes out, you do it that way. So there's also for group distribution, which I'm just puzzled that I don't have a group distribution here. There's another one, group distribution. There is none here. Supposed to have one here. So that's that. Any question? No question. So it won't be complete if you don't do the group distribution. Okay. Let's calculate mean for group distribution. But you know, if you have a table, like something like this, supposed to have this group distribution somewhere written. Surprise it's not here. It's written somewhere else. You have a table like this, in case it comes out tomorrow. Markers are all dying. And you now have, let's say these are the scores. 2, 5, 8, 10. Then you have frequency 5, 2, maybe 5 again, then maybe 3. These are the frequencies. So to answer this question, that's when you use the second formula. You understand? So you now draw something like this. Such that your x will be what? You write your x 2, 5, 8, and 10. Then the f will be what? F will be 5, 2, 5, and 3. You will now look for f of x. You understand? Before you start solving. So you get f of x just means f times x. So what's that? F, these are f, these are x. Which will be this times this. So 2 times 5 will give you what? To give you 10. 5 times 2 give you what? Give you 10. 8 times 5 give you what? Give you 14. 10 times 3 give you what? 10 times 3 give you what? 10 times 3 give you 30. So you now add all the f. If you add all this f, what will it give you? 5 plus 2 is 7, plus 5, 12, plus 3 is 15. So that's 15. Just from this question from my head and it's making sense. You will now add all this one also together. This symbol means to add. So if you add this your calculator, what do you get? 10 plus 10, 20 plus 40, that's 60. Plus 30, that's 90. This question is making sense. And I just formed it from my head just now. I didn't even check it. 10 plus 10, 20, 20 plus 40, 60, 60 plus 30 is 90. So now, the mean x vinculum is equal to summation of f of x all over summation of f. So the mean is equal to summation of f of x is what? Is 90 all over summation of f is what? Is 15. Don't mind my 5 is sleeping. So now 90 divided by 15 will give you what? You've seen 90 go how many times? What will it give you? You see for 15 is already 30. You understand? So this is 30, 30, 30. So that is how many? 1, 2, 3, 4, 5, 6. That's 6. 15 here, 1. 15 here will be 6. Oh, I forgot to have calculator. So we have 90 divided by 15 is equals to 6. Yeah. So the mean in this case is equals to 6. That's how you calculate it if it comes in this form. But if in the form of a discrete data, you can use that method. You can use this one for this one for this. But what of when it is in form of a group data or in form of intervals? They have class intervals. Let's go straight to that. So after I do assuming they were done, I don't need it to be excessively long, unnecessarily long. So let's go to mean again. Another case. The case that she treated in the class. We're talking about the mean. When we are talking about when in the case of group data. You understand? So group data with class intervals. Say example, compute the mean of the data, or some say data presented in the grouped frequency distribution table shown below. Okay, where is the table? Let's show it. 1, 2, 3, 4. 1, 2, 3, 4. Do you know she can even tell you? I said a question where they say answer it with example. So you have to practice an example outside. I think which year was that? You get your example ready, rehearse it outside before you come into the exam hall. Because that one she did not even give any question. She said form it yourself. Class interval, frequency F, midpoint. Midpoint is our x, then the f of x. This case is like this. It's actually longer. One, two, three, four, five, six, seven. Okay, so we have 4 to 8. We have 9 to 13. We have 14 to 18. We have 19 to 23. We have 24 to 28. What else do we have? I hope you can see the down part. I'm afraid to go down in case you can't see. Who is next? 29 to 33, 34 to 38. In case you say, form this question yourself and answer. Remember, where the upper interval ends, that's where the lower interval of the next one starts from. Lower interval, upper interval. You understand? Lower, upper, lower, upper, lower, upper, lower. Where this one starts, ends, is where this one starts from 8, 9. You see it? 13, 14, 23, 24, 33, 34. Like that. In case you say, you should form it by yourself. Then you now put total under. So this one, F, it means frequency. F of x means F times x. So what is this midpoint? We'll find out now. So in case you are giving frequency or you create it by yourself, you can create the frequency by yourself. So you have frequency of 5, 3, 11, 7, 12, 6, and 9. So the summation of everything is what? If you add all these things together to give you what? F of x. So find out what that is. So what is our x? Our x is, you will add this 4 plus 8 together. Whatever you get, that's what you're going to write here. You add it together and divide by 2. So that's how you get this place. We call the midpoint, the middle. You understand? Like she taught us in class. So now to get the midpoint, you now say midpoint. Midpoint. To get midpoint is equals to 4 plus 8. That's the lower and the upper interval divided by 2. 4 plus 8 give you what? 12. Divided by 2 give you what? Give you 6. So you put 6 here. And that is your x. And for the second one, 9 plus 13 divided by 2 give you what? 9 plus 13 give you what in the first place? That's 22 divided by 2, that's 11. No, 22 divided by 2, that's 11. I hope I'm correct. can check and see if I'm correct. The next one, 14 plus 18 divided by 2. And that will be what? 32 divided by 2. And that's 16. Hope I'm correct. Please confirm if I'm correct. The next one is what? 19 plus 23. That's this one. Divided by 2. We give you what? 42. Divided by 2. And that's 21. Hope I'm correct. So you put 21 there. If I put it 16. Woohoo! Next one is what? Next one is 24 plus 28. My red marker is going. So that will give you what? 52 divided by 2. And that will give you what? 36. I hope I'm correct. That's 26. It should be 26. 26. So that's 26. So the next one is 29 plus 33 divided by 2. And that will give you what? 62 divided by 2. And that will be what? 31. I hope I'm correct. Yeah. So the next one is what? 34 plus 38 divided by 2. So you add this place and this place divided by 2. So that will give you what? 72 divided by 2. And that's what? 36. I hope I'm correct, yo. So you write it 36. That's how you do it. So we have to move over to the right side to complete this table. So to complete the table, you now have this times this is f of x. I mean f times x. So 5 times 6 will give you what? 5 times 6 will give us what? Give us 30. 3 times 11 give us what? 33. 11 times 16 give us what? 11 times 16 give us what? 176. You do the math. You are doing measurement and evaluation, so you cannot dodge calculation. Okay. 7 times 21 equals 147. 147. In case you can't see it, I'm calling it out. Then we have 12 times 26. This times this. We'll give you what? 312. Then we have 6 times 31. Give you 186. Okay, we're almost done. Thank God. 9 times 36. We give you 324. You will now add everything together. That will give you your summation of f of x. I hope you can see it. So summation of f give us what? Summation of f give us what? You add everything together, and that will be 5 plus 3 plus 11 plus 7 plus 12 plus 6 plus 9. That gives us 53. So it's 53. Then summation of f of a. I hope you can see this down part. Summation of f of s will give us what? 30 plus 33 plus, add with me with your calculator so in case I make mistake, you can correct me. 147 plus 312 plus 186 is equal to 884 divided, no, 284. Did I miss anything? Seems not to be complete. I've added 324. No, I've not. Okay. Plus 324. Give you 1,208. So that is the summation of f of x. So you can see our work here is almost done. Our work here is what? Is almost done. So let's move faster So from there now we have summation, we have x bar, x being column, that's the mean, is equal to summation of f of x, that's summation of f. Yeah, this mean, the mean, this represents the mean. So summation of f of x is what? Is what? Thank you, God bless you. Put hands together for her, 1208 all over. Summation of f is what? Is 53 all over 53. So what will this give you if you divide it? So we have answer divided by 53 is equals to 22. For my calculator is 22.792. But the woman said you now approximate, our teacher, our lecturer says you approximate to 22 to 2 decimal place. So that's the answer. That's how you put it. You first write it like this, then you find out. So you're not going to lose half mark because you know she's very technical. So set it to 2 decimal place, so you leave it like this. Any question? If there's no question, we move. What's the next one now? The next and the last is his attributes. After his attributes, we now go to the assuming. After that, we are done. Any question? Ask again. No question. Okay, good. Thank God for that. So his attributes is that it is considerate because it considers every value in the data set. It is considerate. It is the most considerate measure of central tendency because it considers every value in the data set. That's more attributes. Then it is not advisable to use it in the case of outliers as another attribute. So we can get as many attributes from the notes and use it. Let's go to the assumed mean. So now we're going to the assumed mean. So let's go to the assumed mean and we'll end it for today. Okay. Assumed mean. Assumed mean. Let's take an example first before we talk about this assumed mean. Calculate the mean of the following data: 17, 12, 14, 15, 18, 22, 10, 9. Using an assumed mean of 18. So they say calculate the following data: 17, 12, 14, 15, 18, 22, 10, and 9 using an assumed mean of 18. So you answer this question this way. The assumed mean A is the what? Is known as the assumed mean. A represents the assumed mean. That's its formula. It is the mean that it is used when the data is large, and we cannot use the direct method as when you use assuming, but this data is not large. But as an example, I think they gave in the class. So assume mean, what does it mean? Assume mean is a score assumed to be in the middle. It's assumed to be in the middle of a data set. And take note, it must be part of the set. Whatever is assumed you are going to choose, it must be part of the data set. You cannot choose anyhow, any data. You must choose one that is part of the set. So to answer this question, the assumed mean is 18. So you draw the table. The formula of the mean x bar is equals to a, the assumed mean, plus summation of x minus a, that is summation of the deviation, all over the total number of scores in the data set. So that's the formula for the assumed mean. That's how you go about it. So if you have any question, you ask in the comment section or in our group. Drop the question there. You ask me directly in my DM. So let's go. To answer this question, you now draw the table. Which marker will help us to end? Markers are all going. They are going. I didn't have time to get. So we have x and x minus a. In this case, if there was f, the main thing is that you will now write the scores. We have 17, 12, 14, 15, 18, 22, 10 and 9, 10 and 9. Yes. So you now subtract it. 17 minus 18. This just means 17 minus 18 and it's equal to minus 1. So that's how you do all of them, minus 18. So I'm going to be 12 minus 18 also. So I need to write this 17 minus 18 or 12 minus 18. If you do it with your calculator, it will give you minus 6. So I need to write 17 minus 18 or 12 minus 18. You can do that working elsewhere. You just put the value, the answer. So 17 minus 18 will give you minus 1. 12 minus 18 will give you what? Minus 6. 14 minus 18 give you what? Minus 4. 15 minus 18 give you what? Minus 3. 18 minus 18 give you what? 0. 0. 20 minus 18 give you what? 4. So I'm positive 4. Then 10 minus 18 give you what? 10 minus 18 give you minus 8. 9 minus 18 give you what? Minus 9. So that's the answer. So you now add everything together. Summation of x minus a. That will give you what? You add minus 1 plus minus 6 plus minus 4 with your calculator. Do the sum up. What did they give you? Okay, to give you minus 27. So that's the answer for that. So, and the number of items, how many are they? Yeah, 1, 2, 3, 4, 5, 6, 7, 8. There are 8. There are 8. So you now substitute into the formula, into this formula. So if you are substituting into this formula, how do you substitute and solve the question? So to substitute into the formula, I have to cross over to the other side. So now you now have the assuming, which is what? 18. Write your 18 plus, coming to the end. Markers are telling me we're coming to the end though. So we have, what do we get here? We got it to be minus 27, so write minus 27 all over what? N is how many times? They appear 8 times. Since they appear 8 times, write 8. This minus 27, I hope you can see it. So now, if you want to avoid mistake, you do this part first. Don't just add, oh, no. So there's a minus here. So you use your calculator and solve here first. So minus 27 divided by 8 will give you what? Minus, what is it? Minus 27 divided by 8. Give me minus 3.375. So you now write it down. You write is equals to 18 plus in bracket minus 3.375. You close the bracket. Can you see it? This is how you should solve it tomorrow to avoid mistake. And that will give you what? 18 plus times minus change to minus. Go step by step. 3.375. So lastly, it will now give you what? Is equals to what? Is equals to what will be the answer? Is equals to 18 minus 3.75 give you for, oh my god, our markers are all dead. 14 point 14 point what? 625. That's what it's equal to. So it's equal to 14.65. If you do this, you have gotten the assumed mean. But you know, she gave us an instruction that we should take it to 2 decimal places. So you convert it to 2 decimal place. This is supposed to go under, but I don't have space, so I'm going to put it up here. This should go under, not up. So your final answer will be this. You will now say, after this step, you now say is approximately equal to this one I know. Approximately equal to approximately equal to what? So 2 decimal place will be 14.63. That will be the answer. Any question? No question. So that's all for today. But there's a key point to note here. That if the deviant score, in case she give us an array, that the deviant score is a high value, using your knowledge of statistics, they say report it. You can come out in a question like that. I don't have markers to write again, so I'm just going to read this. So if the deviant score means, for example, you have an array. We are done with assuming, we are done with today's work. I just want to put Jara. For example, you can pause at any time and come and copy, then adjust, because you can say you should set a question by yourself. That mark, I'm going to just read the probable questions that can come under this topic. So if the deviant score is a high value, how does it affect the analysis of the data? So now, this is the answer you write for tomorrow. Say it will make the mean value shoot up when the deviant score is a high value. For example, if you have 50, 51, 50, 51 in a class of 5 people, this is the score. And somebody now scored 99. You can see, if you do calculate the mean with these values now, because the person has scored 99, to make the mean value shoot up, and it does not describe this set of data. It's not saying the truth about this set of data. You understand? Or should I show you what I mean? If you add 50 plus 51 plus 50 plus 51 plus 99, divided by that to get the mean. I mean I did 1, 2, 3, 4, 5 divided by 5. So that will give you what? That's 50 plus 51 plus 50 plus 51 plus 99 is equal to what? Divided by 5. It will give you 60.2. 60.2. You can see. So this value is not saying the truth about this distribution. Majority. What the majority get? You understand? A mean is supposed to describe what majority got. You understand? Major performance that describes the way their performance is. Majority did not get 60 something. Majority got 50 something. But if we do away with this deviant score, because she said, how do you solve the problem? He said, you do away with the deviant score. You do away with the deviant score or the outlier. We now calculate the mean again with the rest. The mean now becomes 50 plus 51 plus 50 plus 51 over 1, 2, 3, 4. divided by 4. That will give you what? 50 plus 51 plus 50 plus 51 is equals to what? Answer divided by 4. That gives us 50.5. 50.5. You can see this shows a true picture of the what? Of the data set. You understand? So this is a more accurate mean than this other mean. So you say when you have an outlier like this, outlier can be in the high side, can be in the low side. They mean extreme values. You understand? For example, if you have something like this, 80, 81, 80, 81, and 2. This is an outlier because it's an extreme value. It's an extremely low value compared to the rest of the data. Then this is an outlier. It's an extremely high value compared to the rest of the data. So when you have these outliers, spelled like this, outliers or deviant score, because it's deviating. So now when you have them, what do you do? She can ask you in a question and say, what do? You will say you will either remove the outlier, search for the outlier and remove it, and calculate the mean with the remaining data set. That's what she said we should do. Or, which is my favorite, you switch to median. You use the median. The part of its attribute is that when you have an outlier, the median is more accurate or more preferred to use. You understand? So because if we use this, let's calculate with this one also. Let's calculate this one is in the case of high extreme high. This case of high extreme value. How did they put it here? High value. This case of high value. So this case of low value. I don't know what will come out in the exam. It may be high value, it may be low value. So for this low value, what will be the mean? Let's calculate the mean. The mean will be what? 80 plus 81 plus 80 plus 81 plus 2, the outlier, divided by 5. What would that give us? So now we have 80 plus 81 plus 80 plus 81 plus 2 is equal to answer divided by 5 to give you what? To give you 64.8. This is not a true picture of this data set. So let's calculate the mean again this time around without it. Let's see how much it has destroyed the description. Therefore 1, 2, 3, 4. So you calculate by 4. So that will give us what? That's 80 plus 81 plus 80 plus 81 divided by 4. And that will give us what? That will give us what? The answer divided by 4. That's equal to 80.5. 80.5. What I'm trying to say is that this mean describes the data set better than this mean describing the data set because of the presence of the outlier. The outlier gives a wrong description of the data set because of its presence. So what do? You now said to answer this question, if it comes out, you will say I will put the mean aside, I will completely ignore the mean, and I will use the median to calculate it. So let's use the median to calculate it because she may say she show it. Don't just tell me the story with your mouth. Show it. So to show it now, you now use the median. So if you want to use the median now, you will now answer that question like this. In case this question that comes out, you will now say, for the case of the high value, if you arrange it in ascending order to calculate the median, using median. Now you now have 50, 50, 51, 51, and 99. So this is a case of odd numbers. Since it's a set of odd numbers, you understand? So you are going to use n plus 1 all over 2 to get the median position. So the how many are there? 1, 2, 3, 4, 5. So it will be 5 plus 1 all over 2, and that is 6 all over 2, and that is 3. So the third position. So is the median position. So the median It's just what 1, 2, 3. This is 1, this is 2, this is 3. So the person in top position is what? Is 51. So 51 is the median. You can see this one and the median is not almost the same thing. You can, I mean, this 51 and the mean when they were just 4 is not almost the same thing. You can see. So this one shows a true picture. You understand? It shows a true picture. Median is better when you have a deviant score. So that's how I answer this question. You understand? So what kind of question can come? My markers are there, so I can write it under this this analysis. The kind of question that can come is she can give you a value, a set of values like this, and I'll tell you that using this data set, calculate the what measure of central tendency is the most appropriate to calculate this data set, and state your reasons why. You understand? She can ask that kind of question. So that's why you now start using all this explanation. So depending on what comes out, it could be like this, it could be like this, it could be an extreme value of high value, it could be an extreme value of low value. You understand? So if you don't understand, you can talk to me in the comment section or in the group. So thank you very much. We are done. Time up. We are done. Let's go for the next one.